Hi everybody, I am Yepeng Qin. This is the presentation for my final presentation for MATSE 556 Polymer and Composite Material for Additive Manufacturing. So today my topic is on 3D printing with electronic sensors and structures. So before we get into details with any electronic sensor and structures, let's take a look at what is 3D printing. So when it comes to printing, everybody would think, all right, I wanna print out something. So you go to the Word or PDF or whatever document you're choosing, and you connect it to a printer, and then you hit print, right? And then the document or say the material you wanted is gonna be printed out on a piece of paper. So to make an analogy, 3D printing is very much like what you were doing with the normal printing with the paper. So, however, it is a three-dimensional process using software instead of Word. CAD is the one of the most popular software that we used, and uh, the purpose of 3D printing is to create a desired three-dimensional object. So as for why it is so popular right now, is it's mainly because it can literally print out a tons of tons of structures that you can never heard of, and it is really difficult for other manufacturing process to actually make this product. So here is an actual printer, and you can see it is a they are printed by the method of a layer by layer structure. So there are two, like up to date, there are two main stream of printing techniques. First one is called FDM, which is fused deposition melting. In this function, uh, researchers or industries are normally using a thermoplastic filament, melt this filament and push or thrust this filament through a nozzle to print a layer by layer structure. Whereas selective laser sintering, they're using a laser as a heat source to melt the polymer, and then they use extrusion or injection molding to actually print out the structure. So why this is interesting? Because it has been developed for the past years, and it has been used in a lot of spaces, in a lot of fields like tissue engineering, like uh, aerospace and automobile. So my purpose today is to talk about the electronics and the electronic sensor and structure. But before I even get started, the normal printed polymer. Here are five main polymer, but the most popular polymer for 3D printing material. They're ABS, PLA, PVA, PC, and high density polyethylene. However, the disadvantage for those polymer is that they are highly insulated, which means if you want to make them a electrical sensor or make them conductive, it is highly unlikely or literally impossible. So the purpose here is to find a material to actually increase the conductivity for the polymer. And this is actually a funny story because I have synthesized cathode material for lithium-ion battery before. Before that, I was using Nafion to mix with the polymer to bind the carbon black. So from another perspective, we can actually enhance the conductivity for the polymer. And uh, the paper here suggested that there are two main binding um, scenario where one phase is acting. The first one is the a highly density polyethylene binding with carbon black suggested that they are in a high fashion. They're in a one matrix, whereas the second one you can see a completely phase difference. So coming up to next, we can see that formation of carbon black particles at the interface uh, gives you a much higher conductivity. And Based on this, people are using polymer to mix with carbon black, for instance PCl, and then they have made successfully made a conductive sensor, and you can see from image B and D here, and they are actually conductive from the LED lights. So now since we have the conductive material that can be extruded or can be 3D printed, now we're talking about the structures and the electronics and the sensors we can possibly build for applications. And I found some very interesting applications where this one is the battery charge protection circuit, and the A is actually the circuit, B is the protection. So based on this method, researchers have built three versions from here, where the first version is just a cube structure where you can put two batteries into the protection with them fully contact to each other. And the second version, they have a lot of enhancement where they can have a smaller microcontroller and it can put lithium polymer cell in it. The third one is mainly for commercial purposes where you can have, say, this dazzling look red, and it's actually USB port charging, so it's a lot more compatible to what we're using nowadays. And in terms of electronic sensors, and people have built, researchers have discovered multiple scenarios where this one, in the figure A, the stringent flex sensors, it has a piezoelectric resistance, which means the resistance will change when they face the mechanical forces. And we can see here when it's flexed, the resistance is much higher compared to when it's unflexed. Based on this property, the glove over here that can be made based on different figures, and using this we can going to detect, say, a human movement for their physical therapy. And the little funny side project is that you can build a smart vessel where you can embed electronic sensors to test the water based on its capacitive response. So the conclusion here is to enhance the conductivity with carbon black, and they have certain phase as the carbon black concentration is more important, contributed more to the conductivity, and based such uh, on such basis we can have a lot more electrical properties and then have a lot more electrical devices, and it looks like a really promising future. And here are all the references, and thank you so much for your attention. If you have any questions, you're more than welcome to let me know.